Hi everyone, Andy here at Maltech again, and today we got another suspension video. Today we're going to be discussing, or actually we're going to be creating a new linkage. I'm going to design a new linkage. There's a few reasons for this. One of the main reasons, we want a longer shaft travel because that creates a lower leverage ratio. For one, it's going to give us a lighter spring rate we can run, which is physically lighter in weight for these TT bikes. Also, it gives us a lot longer shaft travel, not wheel travel. We're still going to have the exact same amount of wheel travel, but we're going to have more shaft travel sticking out. So always the lower leverage ratio you have, the more shaft travel you're going to have on the bike. We're also going to design this as a dual linkage setup. So when you buy a linkage, you're going to get the front and the rear link from now on. Before, you just got the front linkage. A lot of guys had thrown a adjustable strut on the back, which actually made the problem worse. Yes, it lowered the ride height, but then they threw away their stock link that they need for our linkage. So another good reason, 0405 bikes, we usually recommend to buy an 06 up linkage for the back, the stock rear dog bone. So that's going to be easier for the customer. It's also going to be better because we don't have to put an internal spacer in the shock. It's going to be a little bit more, probably $25 more, just depending on the CNC cost for this linkage, but it's also going to work better. Probably going to be 6 months from now, I'm guessing. Time we get all our testing done, we got a few pro riders who are going to be running this linkage, trying it out for us this year and giving us feedback on it, see if we need to change anything. Still the same progression rate. I'm real happy with our progression, what we have. So the difference in the leverage ratio from the beginning of the travel to the leverage ratio at the end of the travel, that's going to stay the same. So, but we're going to be able to run that lighter spring, longer shaft travel. When you hit the gas off the line, you're going to be less likely to go down and tap that bottom out bumper, which usually blows off the rear tires a little bit. So we're going to get more forward by out of the corner and off the whole shot. So let's get to it, making a new linkage. Okay, we have our other swing arm mounted on the bike. We've got the bike raised up. You can see how high we are off the ground. And the rear tires are still touching. There's no shock in there or anything. Might note, first thing you ever do before you start measuring a bike up is air the tires up. So we've got them aired up now. And we're going to go in. We've got our old linkage on still, and if you notice, I don't know if you can tell or not, this has got a stock carrier in it, but one thing to pay attention to is you want that in the middle position, and that way you don't want it, you want it halfway between the chain being tight and the chain all the way loose position. That way we're in the mean of travel, which is the middle of the travel. So this is kind of an average of anywhere someone's going to have their chain adjusted. We don't have a chain on there, it's just hanging here right now. We're just mounting this up. We've borrowed this swing arm. Another thing to mention is this swing arm length is a 17-inch swing arm. This is kind of middle of the line also. So we want to set this linkage up that we're creating or designing for the middle of the travel range. That way it works out. Okay, well, we found a spot which we have marked, and we're not going to show that on camera. It's pretty simple to figure this out, but this is where our extended compressed link come together. Now, this is where our stock extended compressed link comes together. So now to design this linkage, we want our hole moved from here to here. And I think by this, we're going to swing towards just making a single link again. It's going to work better. I thought maybe this intersection point was going to be closer to this rear hole, but it's not. So since it's here, I think we're going to try to design another link. Unfortunately, people are going to have to buy a stock rear 06 and up dog bone for this to work, but just the way it works out. So now we need to indicate where this center point is. So the way that we're going to do that, I have made sure that this drill bit fits snugly in this hole, and I am running it up and down and centered it. Then we go and we zero our dial indicator, our digital readout. Now we need to know the distance, and I made sure whenever I swing over to this hole that it is perfectly in line with our table X axis. So now we know that from the measurement from this hole to this hole, and I've marked it here, is 9.296 inches. And if someone bought our linkage, you can see, you can measure that up. But what we need to do, we've drawn a straight line from this hole to this hole. And I've drawn those here, this circle and this circle. So 9.296 inches. Now we need to know off of 90 degrees from this line how far it is to our new mounting point. And the way we're going to do that, I'm going to center punch this intersection line. Then I'm going to take a center finder and we're going to move it to this point, and we're going to see exactly where our X and Y axis should be. This is our 0 mark here. So we're going to call this 0. Okay, we put a center finder in here now, and you can see that this moves off to the side. So what we're going to do, we're going to center it up, and we're going to run it down into the center of our punch mark. And then we're going to move our table. You can see that it's moving off. So we're going to move it until there's no line showing around this center finder, which is right there. Then we're going to go up to our digital readout, and you can see that our x-axis is 1.663 and our y-axis is 1.535. We'll go back down here, and what that means is 1.3535 off of this line, center this hole, and then we are 1.663 off of this line to this line. So now we're going to go to the computer and we're going to design a new linkage. Wow, how good of information this is. So you can see we drew a line, our distance from our 0 point, and we've set a circle here, and this is our 0 mark, and we've measured down, we drew a line 1.3535 down, and we're 1.663 over, and drew another line in the center of our circle. You can see is in the center of this line. So now we have these, and we can go in here and we can delete. We know that we're good on where we're at, and we can delete each one of these out. Delete all those, and now we're going to start designing the linkage now that we have all 3 points in where we want them. So I'll be back with I don't know how good this screen is. It looks like we got some reflection on here. I've got all the lights off in here. Just real sunny out today because we've got a lot of snow, so there's a lot of reflection on here, it looks like. So hang tight, and we'll be back with the drawing around our linkage. Okay, after a little time, I've designed this linkage, and we've got all our points selected here, and they're in the right positions, and really we've got to draw around it. We have to keep in mind that we have to have some meat around the outside to make sure we have some strength. We put some holes in the middle with a chamfer inside, and that's going to lighten this linkage up just a little bit. Not 100% positive on this design yet, but I do like the way it looks. I can actually 3D this model too. Alright, I had to restart the program. For some reason the 3D image wasn't working. So now let's see what a 3D looks like. And you can see I've got a radius inside with a flat in the bottom and the holes through, and we've got quite a bit of meat here on the inside. So you can see what this linkage is going to look like when it's completely done. What we're going to do now, we're going to actually make a prototype, and then we're going to test this linkage out. We're going to see what spring rates it takes, how it feels on the bike, make sure everything pans out like we want it to, and then we're going to start our testing process. Now we've gone in and printed out a copy, and we can verify, and we've printed this out as actual size too. We can verify that everything's going to clear. I might go on here. I have a clevis we can add on to here also, just to see. p.e.p has the smallest clevis, and the reason we've got this cut out here is for the spring to clear, the spring retainer on the bottom of the shock. So I'm gonna do that in the program, add that to this linkage, then we can take this back to the bike and we can kind of eyeball it up and see if it's gonna fit or not. So now we're gonna check for clearance. I am going to paste in a p.e.p shock clevis. Okay, and now it is flipped the wrong direction, so let's go in here and flip this. Now we're going to move it into position. That locks it in, and you can see we've got clearance here for this linkage. We can also, we'll probably print this out, I would say, and then we're going to kind of align it and angle it, make sure that this angle is right. If it's not, what we can do, we can change this angle on this shock, and we need to set a pivot point here, and we can pivot this shock. Let me see if I can get that to work. There we go. We double click, we move this pointer down here to the center of this, and then we can pivot this linkage, or this bottom of this shock, to where we want it, and we can make sure we have plenty of clearance here. So we're going to move it to the maximum, which is right here. We're going to print this out, and we're going to see if it clears or not. Okay, I've printed this out, and I've got the wheel off of here so it's easier to see, and you can see that I've got the old linkage mounted up and I've got the new linkage. You can see it doesn't take much to make a huge difference either. And you can see also we have the bike at the extended length height, and you can see we've got plenty of clearance here for a shock. I mean, it's going to be at an angle pretty much straight up from here. So we've got plenty of clearance there. What we're going to do is put this bike at where it's going to compress to, and then we're going to put that clevis that we printed out, and we're going to see how much swing we've got and what angle we need it to be, and make sure we've got clearance. Now we've got this bike fully compressed, and you can see how close it is. I'm laying on the ground under here trying to get you guys a good shot, but we've got the bike compressed the way it's going to be. And what we don't want the center line of the angle of the shock going to be any less than what this angle is. We want it more upright, because this is going to be our maximum clearance angle here. So what I did, I just tied a string to the upper bolt mounting hole location, And so then I can bring this down and I can bring this even or right in line with the bottom shock bolt, and we can see we've got tons of clearance. This shock's still going to be pretty upright. This is going to work really good too, and that's why our linkage works good. Also, we designed this so it has a more upright position. Some of the no links, all the no links on the 450R for TT guys tried to do it. The problem is the shock is laid down like this whenever it's fully compressed. And what happens, because you have a leverage change whenever you lay a shock down. A no link isn't supposed to have much progression, and that's why on the 250Rs it worked with a no link. The shock was more upright all the time, whereas when we did it on the 450Rs, the mounting location, the upper mount on the frame, that's why they changed them on the 250R also, is they moved that towards the back more, and that way you had more of an upright shock whenever you got done with the full travel of the wheels. So it didn't change the leverage on the shock. It acted as a linkage system, but the problem was it was in the wrong direction. Instead of going from a high leverage ratio to a low leverage ratio, it went from a low leverage ratio to a high. It was backwards. So that's why it's really hard and you can't get that to work. We've tested it. It doesn't work. You've got way too much of an angle. The shock is almost laid flat whenever it gets to full compression. And I hope this explains. We're going to make a prototype. It's not going to look anything like this. Really don't need to. All you need is the 3 hole positions to do testing and feel what the bike's going to feel like. We're going to see what the sag is. We're going to get see what spring rate we're going to need for different rider weights. I'm going to use my weight. I know what the sag was with the old linkage. Should be lower than what it is now. I was at a 225 mainspring with the old linkage. We should be a lower, because we're going to a lower leverage ratio. We're going to be a lighter spring, which is actually physically lighter too. But we're going to have a lot more shaft travel sticking out. And actually, I can show you what that looks like. Here is a factory shock. We got a couple of them here we're working on. And here is one that we've modified before. And you can see the difference in shaft travel. We're going to go from this setup with the old one, the old shock, and we're going to have this much travel with the new shock. So you can see there's quite a difference there. It's going to really work good. I've set the bike back on the ground, printed out another linkage, and that way I've got this in the far back position with the p.e.p clevis on there now. And I'm going to take this string, and you can also see that it's fairly straight up and down. So our shock doesn't hardly move, which makes this linkage work so good too. Throughout the entire travel, it stays about the same positioning. Alright, I'm not going to show the entire machining process, but I'm just going to show you. We blued this part and we're going to did a layout on it, cut it out just to give us a reference, and that way we know kind of where our points are, so we don't mess anything up. We only want to do this one time. So let's get to machining then. I drilled all my coordinates now, and so everything's perfect. Bored my holes out so these bearings will press fit, and once I press them in, then there won't be any binding issue. I've got them tight tolerance on that. And now I'm going to rough cut this out, and then I'm going to come in. I'm still going to make it fancy, even though it's just a test piece, but might as well while I'm doing it. So I'm going to get to roughing and I'll be back. Alright, here's the linkage all cut out. The prototype is roughed out, and now I got to get to milling on the milling machine. And we're going to cut it out. So we've got a little thinner here. I knew that to begin with because the chunk of aluminum that we were working with wasn't big enough, but that's what I had. So if this gets by and doesn't break, then we know we're plenty strong enough in this area. Alright, we got one more pass left here on the milling machine, and we'll be done. We're gonna chamfer these holes, and then we're gonna deburr the part, press the bearings in, and it'll be ready to test. Send it out the door, and then we'll get some feedback on this, and I'll get a video of the finished product when it's done, deburred and everything. We're gonna run one more pass here after this is done. Go back, engage our power feed, and on to the last pass. We got a good sharp bit in here, so it cuts really good. Here's our finished product. We've got it deburred, got our new bearings pressed in, everything works nice and free, so we did a good job on making our holes just right, bearings pressed in perfect, seals pressed in perfect. Got it all deburred. You can see, turned out pretty good. So we're gonna get this on the bike. Like I say, on a new linkage, we're gonna have more meat down here at the bottom, so don't be worried about that. We're gonna get on the bike. I say if this one lasts, it's definitely gonna last on a other linkage, so I don't have any problem. I don't see why this won't last at all. So let's get this on the bike, and we're gonna run the bike through its travel. We're gonna see what sag is now with the new linkage compared to the old linkage, and I'm sure it's gonna take a lower spring rate because we're going to a lower leverage ratio. So let's get it on there. Okay, I've got the linkage mounted up. We're gonna see what our travel looks like, and we're gonna see if everything looks the same as what we did with our piece of paper here that we had hooked up to the other linkage. So let's run it through its full travel. There's the full travel. So everything looks good. We're going to mount the shock up, put the wheel back on, and see what we get for sag. Alright, we're going to run this through its travel. It's sitting on the ground right now. I'm going to raise up. There's where the shock tops out. Now we're going to go down, and it's nice and flush all the way down through the travel. There's no harshness at all. This linkage, it's ready to go testing. Also, you can see how much shaft travel we have. That's with the bike just sitting here. Find another GT linkage that has that much travel that's also low ride height. Now I've got the grab bar picked up. So I'm going to set this down, set it up so you can see what it looks like when I get on the bike. Let's get a side shot here. You can see the bike is low. Let's see if we can get it so you can see how high the bike is off the ground when I get on the pegs. You can see it drops down. It's nice and smooth transition. We can pick up. That's the top of the bike, topped out. And you can see it's a nice smooth transition all the way through. No harshness. Now I'm going to get you set up so you can see what the how much travel we have before you get on the bump stop when I get on the bike. And this is going to be good for hole shots is what this is going to be good for. That way you don't hit the bottom out bumper when coming out of the corner. You're just going to use the bottom out bumper now for harsh hits, flat landings off of jumps. Okay, I've got this set up. I didn't even have the bottom out bumper slid down before, so there's more travel. It was about like this before, and I didn't have it slid down all the way. So you can see how much shaft travel we have. I'm going to pick up on the bike now. So we've got that much shaft travel, which you'll never see that with the TT bike that has this much wheel travel, and also bottoms and extends at the right point, and also has the right ride height. So I'm going to get on the bike now. We did drop 25 pounds, so one spring rate lighter than our old linkage setup. So that's physical weight, and just because it's a lower leverage ratio, I was expecting this also. So I'm going to get on the bike now, and you can see the travel that we have left before we hit the bottom out bumper. when I'm sitting on the bike, and now I'm sitting on the bike. So when we're ready for the whole shot, you can see how much more travel. This is me jumping up and down. Now I'll push on the back of the bike, and you can also see most bikes you're going to be on the bottom out bumper. I'm actually have all my weight right now on the back of the bike. So we've got that far before we hit that bottom out. We may be able to even run a lighter spring rates yet. We're just going to have to do testing first just to see. We might be able to run that lighter spring setup, which is going to be a plus. What this does too is it lets the valving react, so you're not compensating for the limited travel with a heavier spring rate. We're letting the valving work. Usually on TT shocks, you're just letting the springs do the work and not letting the valving do the work. So this is going to let the valving come into play, and it's going to be easier to tune also. I hope you all enjoyed this video. I like making it. I hope it's very informative, get you thinking. If anyone's wondering, this is my own bike. I don't know if I said that in the video. I purchased this off a customer. We built this bike in-house. It's a good type bike. Hauser A-arms. It had a Hauser swing arm that we took off. This was a heavier rider. I had to set this bike up for me. We actually drag race this bike. There's probably some videos on YouTube of me dragging this bike, running I think 780s in the 8 mile asphalt, I think at 84 mile an hour. I actually needed a shorter swing arm for drag racing on asphalt, believe it or not. Swing arm length is pretty important. Another thing, I don't know if I mentioned this swing arm on this bike is a Walsh. It's a 17-inch from center eye to center, or center pivot bolt to center axle. So just in case you're wondering, we like to pick our swing arms per rider weight and also by their height, because some guys will set back farther. You know, if you get a taller legged rider, they're going to tend to be able to set back and put their weight back farther. So we're going to compensate for that, and we're going to run a different length swing arm. So just contact us if you're ever curious what swing arm length. We'll let you know what we recommend. Give us your weight, give us your height. That's all we need, and we'll recommend a swing arm length. This does play into effect to cross country and motocross setups too. Swing arm lengths and a linkage. So you just don't realize how important it is. The TT guys, they're not getting traction. They can see the guy in front of them is, and they're pulling away. You know if you're searching for traction on TT racing flat track. But motocross, cross country, those guys just kind of adapt. It's not the right way to do it because you're actually wearing yourself out. You need to run the right swing arm length and the right linkage setup and right shocks all the way around. Setup is just huge. So if you got any questions, please give us a call. You can go to our website also, and we'll be more than happy to answer any questions. As long as we're not on the phone, we'll try to answer. Leave us a message and we will call you back. I hope you find this video real informative. Please post any. If you got any suggestions for videos, I'm open to anything.